Hi everybody, thanks for staying awake. My name is Alan Brown with Odyssey Space Research. Matt Benson couldn't make it. Here he's got a presentation tomorrow, so that's how things go. I'll make it fast. Obligatory company background, but Odyssey's been around for quite a while, and we do interesting stuff with lots of different vehicles, many of them visiting space station, many of the things that couldn't even make this chart, but it's been fun, and we got a lot of cool people doing a lot of neat stuff, including not only flying vehicles, op support, training systems, but a lot of stuff with flight software and CFS. Some of this might look familiar. We presented on this topic last year, but even more things pop up on this chart, and I'm going to be down to an eye chart really quick. But the nice thing has been working with a lot of these fine folks at NASA and in and outside of NASA on CFS on a variety of things over the last couple of years, and all that continues in a variety of ways. And many of the things we've talked about today, Odyssey folks in different aspects have had their fingers in, and so it's been really cool. So when it comes to outreach, we like to talk about the Space Lab for iOS. That was the first iPhone flown in space, and so we like that. And outreach is really important because every time we talk about it, we get folks inside our company and outside our company talking about, hey, how do I learn about this, that, or the other? And materials that are for training are just hard to put together. And so that's part of what we're going to talk about. Okay, so when this was conceived a couple of years ago, really it was Lori Prokop at NASA who was saying, look, I want something that people can jump in and learn by doing, and she's right. So let's focus on basic CFS application development. And to do so, you got to really kind of understand at least the basics of what is CFS and how you do mission integration. The second thing is you want to test like you fly and fly like you test. It's said around NASA all the time, but really you want to engage somebody. It's really nice to make it real and get some hands-on hardware. What better way to do flight software than to have flying hardware? And so we thought, well, let's put it on a drone. And drones have become a big deal, but really you can focus on flight software application development, and it doesn't matter if it's a drone or a vehicle out in space. It really ends up giving you a lot of the same value. For the flight software development process, when it comes to space vehicles, they are different than drones. Drones are a few bucks. Space vehicles are a few $1,000,000 or more. So the testing for an integrated simulation environment that you do really ends up being more critical than sometimes the flight software. That you're right. Sounds weird to say that, but if you don't start thinking about testing at the very beginning and how you want to integrate that with your software process, you're really going to end up on the losing end of things later because you're going to discover too much stuff late. And so let's find a way to get some exposure to a simulation and ground tools that you use in the test environment, in the flight environment. So test like you fly, fly like you test. Aiming at the university level, but this is becoming very useful for industry engineers. Kind of hard to gauge what level you want to aim at in terms of knowledge, but assuming some software development exposure, and we're going to include everything that we can that's already publicly released. So the goals, make it interesting, usable, make it representative of a minimal flight software process with all the different things that you would include, and let's get it out there, let's make it available. So like many others, we went with the Linux VM image. Everything's there for the demos, the tutorials. So we basically want to deliver just a VM, some basic setup instructions, and the user shows up with a laptop which has Wi-Fi, which is how you connect to the drone, and we're going to talk about the drone we selected, which is a Parrot Air Drone 2.0 quadcopter. And actually, as it came out in the end, the drone is a little bit somewhat optional. It definitely can be shared because if you're in a classroom situation, you're not going to have 30 people in a room with 30 drones. That would get a little crazy. But you don't want to do it because you want availability of the hardware to necessarily slow down someone's adoption or understanding of the material. Here's the drone that we've been looking at. Again, we presented this last year. It's been a workhorse, and because it's running Linux and it's a very open API, we're interacting with it over UDP, over Wi-Fi. We don't have to get into the firmware. We just use the existing interface. Makes it nice and simple. We don't have to worry about messing with the drone. We can concentrate on CFS. And that means we can run Linux on the VM or on the Air drone itself. So for the components and packaging, this is probably similar to what you'll see for other VMs, but it's a CentOS 64-bit Linux distribution. All the CFS releases from SourceForge. The trick simulation, which we mentioned earlier, which is on GitHub. Well, you got the toolchain for Linux, 64-bit, 32-bit, and the ARM cross-compiling toolchain for the drone. And we included the on-target debugging with the GDB server. We got Eclipse in there with CDT. We got the demos and the tutorials and all the references that we could inside an editable wiki inside the VM. And that ended up being really useful because when a user sits down, they got a VM, they can start changing the wiki, making notes and stuff as they go along. They can write their own issues if they want. There's Git in the VM. If they want to stand up version control and everything else, they can do that right there. We also called out the very cool CFS Performance Monitor tool that is delivered along with the CFS open source release, and we've got a tutorial on that. And we made some minor mods for streamlining things. Schedule table generation, the script is already there, but there are a couple of small missing pieces. We filled those in. We changed the PC Linux PSP to ARM Linux PSP, and all that was some compiler flag changes. Added a little bit of extra functionality for generating SC tables, and a minor change for the MQs to build on the drone kernel. This is using the CFE 6.5.0 release, which is currently out on SourceForge, so that's the same thing. Here's a screenshot. I wanted to bring it, but I'm glad I didn't because there's no way I could fly a drone in here. But it's real. There's a CFS screenshot. This is what you would see in your virtual machine on your laptop. We've got some handy tools at the desktop where you can get into the Outreach Wiki. You can telnet over to the drone. You can launch YAMS, which is what we're using as our ground system. You can fire up Eclipse. You can fire up the TrickSim, which we've got a simulation that has a basic model of the drone itself with the flight interfaces and a quick link for the CFS Performance Monitoring tool. An example course material. This is for the first demo hover sim. Demo hover. Sorry, I get trapped up in that terminology. There's a hover that is a demo, and there's a hover that's a tutorial. The demo will show you, look, you can run CFS on the drone. You can make it do things. Then the tutorial will take you how. How do I do this? How do I change that? And start walking you through it. So each step of the way, we have it in the wiki. You can go back and forth, jump around, hyperlinks, etc. Here's the TrickSim that you can get open source, and this is our TrickSim with the drone models running. And there's CFS running on the right, and the interfaces with the sim, and we've got a UDP interface. So all the flight software is running inside of CFS, interacting with the drone. The flight software doesn't know any difference. For YAMS, we didn't do too much customization to YAMS, but there's a CFS plugin, which Matt Benson for Windhunter Labs donated. And we built some custom display pages. But users can go in and make their own pages with YAMS and display whatever they want for their app. We've got a lot of I think we've got all the CFE core in there and some of the CFS apps as well, like enabling telemetry with the TO lab. So for the content, we're stepping the user through a sequence of tutorials and demos to kind of get their feet wet and educate them at the same time. So obviously you got to install and configure the VM. Connecting to the drone can be a little tricky with firewalls, so we went through a lot of work to break down all those barriers so that when you're done with that, you have a good working installation. Getting started, giving overview material, kind of collecting a lot of stuff that's already been there, but packaging it up and making it right there available in the wiki. We go in and immediately give them a hover demo, which is exposing them to the build tools. If they've never seen the CFS build process, this gets you right in. It uses the Goddard Classic make, but there's no reason the users can't jump up on CMake if they want to. It uses the command and telemetry interface with a CI lab and TO lab that's publicly available. And you immediately can fly the drone, watch it lift off, hover, spin around. You can give it some basic flight commands. We tell them to keep it down until you learn how to fly it, but you're up and running. And the next thing is, well, let's do the demo, let's do the hover, but let's do it in Linux. And then at that time, that's when you get to build it, run it, and do it in the sim. So you can see that other than a few build differences, you really get the same effect. We can move into the Hello World tutorial, and then we do a demo, which is introducing the concept of CFE tables. And we use a stored command app because it's very convenient to send different commands to the hovering drone. And so we show them a tutorial of how to do CAN maneuvers, integrating an app. So we give them one with SC already in there, and then we give them a CFE installation where there's no SC, and they have to learn how to integrate the SC app. And we actually give them an app checklist. Here's what to do if you want to integrate an SC app. You have to worry about app IDs, performance IDs, what do you do in your make files, just stepping them through it. And then start testing and debugging on the simulation. Now, we give them the ability to create and run their own table. Before, when they're doing the demo, we say, don't do anything crazy. and wait for this tutorial. We show them how to do it in a sim. They need to do crazy things because we're walking them along trying to teach them why you want to use a sim. And here's the next reason. When you put CFS communicating over the UDP interface for the drone thinks it's talking to your phone where you're flying it, and it thinks it's under perfect control, that there's a user on the other end, except CFS is now in the way, and so CFS is actually interrupted the watchdog that's on the drone. So if you give it a command and then pull your command in telemetry, you've lost control of your drone and can fly off. We show this to them in the sim and say, this is why you test in the sim first. Trying to get people to realize that you want to test things with flight hardware in a sim. That leads us into the next thing, which is, well, let's fix it. Let's make an app that will solve that problem. And so we put in our own CFS watchdog app, and it's just a basic loss of comm watchdog. If it doesn't hear any command and telemetry for a certain period of time, configurable, then it'll auto-land the drone immediately. And so basically you put that functionality back in. And again, you do that all in the sim, test it all in the sim, and then at that point, we let the user go and fly the drone if they want. They've got all the tools to put stuff on the drone, add their own apps. We give them at least the basics. And the final thing is the performance monitoring we thought was very important, and the tool is so cool that let's actually walk them how to put in the performance IDs, take the performance measurements, and understand what's going on with the code execution. So with all that, we ended up having to do a lot of documentation, build instructions. How do you debug? How do you debug in the sim? How do you debug remotely on the target? How do you work the YAMS telemetry and ground system? Let's talk about the apps that we're supplying versus the apps you're making. We came up with a lot of comments and concepts that we captured from many people around the CFS community about what are good and bad ways to design your app, things you should and shouldn't do with your startup scripts, what you should and shouldn't do with libraries. And a lot of this percolated up after us seeing mistakes that we made or things that we heard and saw other people feedback to us. So it ended up pretty good. We got some checklists that I think folks will find useful for app integration. Some hints and tricks about what to avoid on your startup script, which will just cause you to waste a lot of time. So we've tried to fill out stuff as we went. That's the nice thing about a wiki. Hey, I hit this problem. It cost me 3 hours. Let's write it up so it doesn't cost a user 3 hours. So here's lessons learned. There is no one way to make a CFS app, and I think the CFS CCB had a good discussion on that earlier this year. But really what it comes down to is how do you structure your app internally with the functions? What kind of message response behavior do you want? Its relationship with the scheduler, housekeeping, upstream and downstream apps that feed it. All these are completely open for design decisions, and there's no one right way. If you're doing a hard real-time, mission-critical Class A app, you're going to want to do certain things. But if you're on the other end of the spectrum, there's a lot of reasons you don't want to do those. And so there's no one right way. We presented one way, and I think just for the community in general, I think that's a fruitful discussion to continue. Again, when it comes to app development, we realize it's not just developing an app. You can't just say, I'm developing an app in a silo. I got an app, but it interacts with a lot of other things. And so you've got to have some minimum knowledge about CFS integration, and that came through. And we started structuring our tutorials and demos more towards walking them through the process so they could start to pick it up. You definitely need command and telemetry tools. I don't care what tool set you use, but you need it from the start. And the engineer really needs to be able to get in there and easily tailor it, especially at the development process. You can't have the development engineer using ground tools unless they can actually easily modify them and turn a ground system into a development system. And then again, for anyone who's making these things, polish takes time and effort. And if you know your audience, you're in good stead. If it's an engineer down the hall or if it's for your local group, much easier to build than for an audience you've never met or may never adopt. So the amount of time and effort, just budget that accordingly. I will say the wiki format looks like a great way to capture stuff. We're using Track. It's not the greatest wiki in the world, but it's something that we knew, and we knew that we could control the image placement, layout, sizing very well. There's plenty of other great options out there, and they're all coming along. So there's no reason you can use one particular wiki or another. Go with what works for you. But the reason we put the wiki inside here instead of publishing it is that we do have to conform to a NASA release process, and so we're releasing a product here. What happens after it's released is open to conversation. But to get this first one out, we went with embedding the wiki inside here. The other thing is when you're building the VM, you got to have a very repeatable VM build system. And then there's some good tools out there. I went with Packer, which is the same people who do Vagrant, and that turned out to be a really good way to do it. And so in the end, I wish I could say it's done, but there's so much expansion that could be possible on every front. You could write novels on CFS app development and still never be done. But I think it's a good first cut, and I've gotten some good feedback from engineers who've used it. So the current status, it's going through the process now. The gears are turning. It's going to come out. It's just a matter of when. And I want to say thanks for Dr. Lori Prokop at JSC and Dave McCombs at Goddard for giving me a chance to come back this year and kind of put a cap on it. And thanks for all the folks who helped develop CFS, Trick, all the reviewers and folks who made it possible. So that's it. Thanks. Questions?
Any questions? Where's the drone?
I know.
You got one. I sent one to you.
Alan's got
Oh,
it.
Alan's got it. I thought
Oh.
you were playing. Alan's got it.
It's a game of who's got the drone.
At one point, you were saying you were flying it at your back. Oh, you bought your own.
So I realized this was originally designed for engineers as a target audience.
No, actually, it was aimed at university students.
Okay.
I probably glazed over that trying to make some time up. It's aimed at university students, but it became so useful for engineers. I had engineers saying, when can I get it? Because I wanted to find out about or I wanted to play. And it's a complete development environment. I wouldn't have any trouble sitting down and doing Linux, POSIX, application development in it right today because it has everything I need.
Awesome. So I work with a high school CubeSat team. Do you think this is going to be over their head?
Probably not. I mean, if they're willing to step up and even look at CFS and software development, they got to know how to compile something. They probably need to know how to step through a debugger. They already know what a wiki is. A 12-year-old knows what a wiki is. I mean, they ought to be able to hit it on the level. And if they're getting any kind of coaching, I wouldn't think it would be a super big stretch. Oh, way back there, waving their arms.
I'm sitting way in the back here. Yeah, my name is Amalai Oyaki. So I have a question. So you used a drone. Has there been any discussion or thought of using this on a sort of a high altitude rocket, or at least a model rocket that goes very high? I took a bunch of high school students to the Arliss Mud Rock event in Nevada, in the Black Rock Desert. We were blasting rockets thousands of feet in the sky, and we had Arduinos in them, and we were, collecting telemetry and things like that. But it would be really cool if we could do something sophisticated and just show them how to use sort of these software tools to do things like having the payload send a message back to where it landed, because sometimes it would land a couple of miles away and we would have to send a car to go and find it or something like that, or
Sure.
or even try to have some kind of control descent performed by the software itself. So I'm just curious if this has been looked at in terms of sort of the rocketry community and things like that, because they have their own little community as well, and this might be of interest to them.
That's cool. I've never thought about doing it with rocketry. I was aimed at drones and flight software development, but you know what? With these tools, I mean, anyone can assemble this. In fact, I really wanted to have the word kit on every page, but it was too late. But anyway, the same tools that you would use to do that are actually in this VM and probably in most of the other kits that have been discussed here. In fact, let's see, where's the other page here? So basically what I had that up for, you got your tool chains, you've got your documentation, you've got your CFS open source releases, you have everything there that you could also pull together manually yourself. But then let's see, over on this page, for the content, if you wanted to do something else with CFS besides flying on the drone, what we found out sort of near the end of doing this is that out of all the demos and tutorials that we have, really, not that many actually require a physical drone there. In fact, you could skip the ones that need the drone and still read it and come away with probably 80–90% of what you need. The point is that by the time you get through examples in the VM without any drone hardware, go through the build, understand the build process, run something in the sim, play with the ground telemetry system, you're already pretty far along to doing that for any CFS system. It doesn't matter if it's R10s, VxWorks, whatever, just Linux makes it more accessible, it's already there. The nice thing is that you could use this for development of CFS apps that you wanted to load onto whatever processor you want to fly. If it's running Linux, or if it's running Linux on a x86, or if it's running Linux on an ARM processor, your tool chain's already here. So it might get you pretty close to, well, it might get you a lot farther along than if you had to cobble it all together yourself.
I might add to that. Yeah, one of your slides showed the trick simulation. So I think you had one slide there. It showed the tricks. Well, yeah, the trick sim are just the tools, but for this thing, we had to build a model of a drone. I could see you substituting that model out with a model of a rocket, and like you said, all the tools that are there are applicable. So it's you know, switch out what you're modeling, and
Yeah, if you wanted to just cut out the stuff that have to do with a drone, use all the tools, use the rest of the wiki, the reference material, the CFS material that we bundled along with it, and you've got a ready-made Linux development environment with an ARM toolchain. Throw your own toolchain on there, and now you've got another development environment that can do something for your project. And so we thought about that as we're developing it, and it's like, wow, it's really useful.
Actually, I have a question, or two questions.
Okay.
One was, have you talked about any universities in a curriculum? When I was out at Smallsat, I was actually approached, you know, where
I
they
think Lori has.
I have
putting.
been collecting. I have been collecting universities who are ready to accept this into their curriculum at some level when it gets released open source. So I think I have like 5 of them now, and it kind of ranges from like you know, an elective I don't know what, special project, to maybe something that could be integrated in with the software engineering course. So I really wanted to sort of, when it's ready, kind of talk to the people at the department to see what they want. But when we were designing it, they were trying to leave it so that you could bite it off as little or as much as you want. Where if you just wanted to do maybe a week project, fine. If you wanted to make it a whole semester, you could even do that. But, you know, and anywhere in between. So, you know, try to leave it up to the department for where it fits in best.
And there's plenty of room for expansion. I mean, CFS application development is so rich, you could spend days and days just talking about tables, the right things to do, the wrong things you don't do, libraries, things you do, things you don't do, interacting with all the individual CFE services. I mean, it's very rich, and it's impossible to cram all that into one VM and polish it up and do everything. So I view this as a foundation, a good foundation, but it's a foundation, and there's so much more rich discussion that can happen on top of this or on top of any of the other kits, but you got to start somewhere.
That was actually my second question, or
Okay.
comment, because Alan's working on PySat, and I thought, well, boy, that's a great, you know, we've talked about it in our kit, obviously, but same thing, and that's where each person could have it on their desktop, because
Sure.
it's so cheap.
It's a VM. If you screw it up, scrap
And
it,
it's
start
just-
over.
and- well, it's
You're
on,
good.
yeah, well, it's on a Raspberry. His target is on the. Is actually the target is the Pi.
Mhm.
So then it has some, and we've talked about table sat and things like that.
Okay.
All right.
Thank you all.
Any other questions or?
Thanks for hanging with me to
Thanks
the
a
end
lot,
of the day. All righty.